AB Calculus Note Card 35, Rolle's Theorem. This is the 35th Note Card Series video inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. Rolle's Theorem, it's an existence theorem, very similar to the Mean Value Theorem. In fact, if you go to Note Card Lesson 34, just before this one, if you have the family of functions for whom Mean Value Theorem applies, within that universe of Mean Value Theorem applications, there is Rolle's Theorem. And Rolle's Theorem, therefore, is a special case of the Mean Value Theorem. So if the language you see is very much the same, that's the reason for it. Let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b. If f of a equals f of b, then there exists at least one number c in the interval from a to b where f prime of c equals 0. And I made a little sketch here at the lower right. And if we have two values, a and b, and I'm going to draw a horizontal line between them right here. And if the slope of this secant line is equal to 0, that would be only possible if f of a were exactly equal to f of b. And therefore, according to Rolle's theorem, there would have to be, and be a mean value theorem as well, between a and b, there would have to be at least one point, at least one number, one point, x value, where there would be a horizontal tangent line, which I mistakenly drew just a shade above here. I'm going to put it right down there. There we go. See? Right there. So that's the essence of Rolle's theorem graphically, but the process is very similar to what we look for in the mean value theorem. The first step, as in the mean value theorem, we find average rate of change. Okay? And if average rate of change equals 0, and of course, if we have continuity and differentiability, we look at continuity and differentiability first, we would say Rolle's theorem applies. Theorem applies, okay? Next step, find f prime of x. Third step, set f prime of x equal to average rate of change. Okay, in parentheses, which equals 0, which equals 0 is equal to 0. And last step, solve for x. And when you have what x is, x would be equal to c. Now we're going to work over a couple problems. Problem 1, determine whether Rolle's theorem can be applied. If so, find c. If not, tell why. Well, the first thing we're going to look for is f of a and f of b, because that's what we need to find average rate of change. So we would say -2 would be a and 2 would be b. So f of a would be equal to -2 to the 4th power minus 2 times -2 squared, which is going to be equal to -2 to the 4th power 16, and then -2 times that'll be 8 So minus 8 would be equal to 8. F of b would be equal to 2 to the 4th power minus 2 times 2 squared, which would be also equal to 16 minus 8. And so as far as continuity and differentiability, we have an x squared, x to the 4th power minus 2x squared. We have a polynomial function, and so we know we're going to have continuity and differentiability over that interval. So since f of negative 2 equals f of 2 equals 8, Rolle's theorem applies. So now we're going to go to the step. Now, as far as what AROC is, we're going to have f of b minus f of a over b minus a. In this case, we're going to have 8 minus 8 over 2 minus negative 2. Well, 8 minus 8 in the numerator is 0, so that's going to be 0. So we're going to find f prime of x, our second step, which is going to be 4x cubed minus 4x. And now we're going to set f prime of x equal to the average rate of change, which is 0, and solve. And so we have a common factor of 4x, and then factoring out 4x, we have x squared minus 1. And so we have x is equal to 0, and also we have x minus 1, x plus 1. We're going to have x is equal to negative 1, x is equal to 1. So we'd say C is equal to negative 1, comma 0, comma 1. So 3 values of C for which there is a horizontal tangent line. And that's what that means. You have a horizontal tangent line where x equals negative 1, where x equals 0, and where x equals 1. Okay, next problem, 2. Let f be a function that is differentiable in the interval from 1 to 10 if f of 2 equals negative 5, f of 5 equals 5, and f of 9 equals negative 5. Which of the following must be true? Well, I like to, for problems like this where I'm given points, I like to conceptualize them by making a little sketch. And so I'm drawing a little xy coordinate plane here to the right. So x, and I'll call this f of x. Yeah, it's supposed to be x there, all right? And so f of 2, so I'll put 2 here. We want f to represent f of 5 and f of 9. And then f of 2 equals negative 5, so f of 2 equals negative 5. F of 5 equals 5, so that would be up here. And then we would have f of 9 equals negative 5, so f of 9 is equal to negative 5. And which of the following must be true? F has at least 2 zeros, and we should be able to see that there's no way we can attach these points smoothly, which would make these a differentiable function, and continuously without going through the x-axis where f of x is equal to 0. So I'm just drawing a little sketch here of something that might have to look like. Okay. Okay, so function might look something like that. That looks like it might fail the vertical line test, but you get the idea. So check mark according to IVT, at least two zeros. 2, the graph of f has at least one horizontal tangent. Well, we have f of 2 is equal to f of 9, which equals -5. Therefore, Rolle's theorem applies which means there must be at least one a horizontal tangent line, which graphically would occur up here somewhere. I'm drawing this horizontal line. So that's a check also. So 1 and 2 are checked. 3, for some c between 2 and 5, f of c would have to equal 3. Well, here, if we draw a dashed horizontal line at 3, we would see that we would have to have at least 1 0. So, yes, according to IVT, there must be some c, x that is c, where f of c is equal to 3. Okay, that's all we have here. I hope this has been helpful. Good luck, and thanks for viewing.